Hi. Good morning, everyone. Let's get started after recording issues. Topic for today, we're going to wrap up BGP and move on to designing IP, and I'll explain what that means in a minute. Just a quick recap of where we are. If you remember, in the context of BGP, we spent the last lecture talking about the high-level goals, the high-level approach, and by and large, we didn't really get into the weeds of how the protocol works at sort of the router level. And so that's what the plan is for today. Quick recap of where we are. All of last lecture, when we talked about inter-domain routing, our model was a topology that looked like the one that's up here, which is what we call the AS graph, or the autonomous system, inter-domain graph, where each node in this graph is one autonomous system. And I hope you remember, but just to recap, you should now know how BGP works at the level of this AS graph. Okay, we said destinations are prefixes. Each autonomous system advertises the prefixes it can reach and its path to those prefixes. And each autonomous system listens to those advertisements and selects the routes it wants based on policy. And we talked about these Gao-Rexford rules for what those policies look like. So at the AS level, you now know how BGP works. The main challenge we're going to address today is that, of course, in reality, there is no such physical entity as an AS per se. What we have is a network of routers and links. And so the real challenge is how we implement that BGP AS level policy making when every single router is acting independently. So how do you actually do a distributed implementation of what we've been discussing so far? Okay. And in particular, within this graph, we'd highlighted that you have certain routers that are kind of special in the sense that they are border routers, which means that one of their neighbors is in a different autonomous system. Okay. So wrapping up BGP means the main question we have left to discuss is how do we distribute this BGP process? How do we make sure that all the routers in an AS are actually implementing what we were saying an AS was implementing before? And so sub-questions are, what's the role of border routers versus interior routers? How do we actually integrate the intra-domain routing with this inter-domain routing? So the two finally have to meet together. Okay. And then what are the actual messages, protocol messages that are being exchanged between routers in order to achieve this? So one of the things you'll hear when people talk about BGP is they'll say, these routers speak BGP. This is just BGP-specific language for a certain way of implementing the BGP protocol. What it means is, when we talk about who speaks BGP, we're talking about which routers are advertising these routes, these different prefixes. And the answer is that in BGP, it's the border routers. So the border routers are what we call BGP speakers. Okay? What does it mean to speak BGP? It means you implement the BGP protocol specification. So if you're looking for punishment, the entire BGP protocol spec is out there. You can go read it. It's many hundreds of pages long. I wouldn't recommend it, but it's there if you want to know all the gory detail. So what it means when I say you implement the BGP protocol, it means you have code running at that router that implements that protocol specification. It knows how to send out the messages that are in that specification. It knows how to receive them and what actions to take when you receive those BGP messages. And that's what we're going to talk about today. Okay? So it specifies what messages BGP speakers exchange, both their syntax and their semantics. So what actions you take when you receive these BGP messages. One point to highlight before going forward, I think somebody actually raised this last time. Not all border routers in an autonomous system have to speak BGP or have to actually run BGP. The canonical example, and this is again what helps scaling on the internet, let's say you had a customer that only has one provider. Okay, so the entire autonomous system connects to the internet through one provider. So this is, let's say Berkeley, for example, has one provider, it's AT&T, that's the way Berkeley connects to the internet. In that case, you don't really need to run BGP. And if you go back to Murphy's lectures on default routes and static routes, we're going to use the same trick here. So in that case, what we're going to do is we're going to say that the provider is going to advertise the prefix on behalf of its customer. And the customer is just simply going to have a default route that says, for all addresses not in my autonomous system, just go to my provider. Okay, so what that looks like is this example here. I have a provider and a customer. The customer has been given the prefix 130.132/16. What the customer is going to do is it's going to configure the routers within its own AS to say, if there's any address that is not 130.132, just send the packet to my provider's network. Okay? That's all you have to do. And in your provider's network, what you're going to do is have a static route that says any destination that is with the prefix 130.132, just send it to my customer. And then the provider is going to play the role of the BGP speaker on behalf of the customer, which means it's going to advertise that prefix to the rest of the internet on behalf of the customer. Okay, so just know that this special case exists. The rest of the lecture, we're not going to worry about this particular case. Any question on these default routes in BGP? Okay, so with that, a second terminology, BGP-specific terminology, is you'll hear this term BGP sessions. What a session is just two neighboring routers that are exchanging BGP messages back and forth. We say that they're engaging in a BGP session. Okay? And so if you look at one of these border routers, they have two types of BGP sessions. One is the session that a border router has with a border router in a different autonomous system, so run by a different operator. We call this an external BGP session, or eBGP session. The second type of session is the exchange of messages that happens between a border router with all the other routers, both border and interior routers, within its own domain, within that AS. We call these internal BGP sessions or iBGP sessions. Okay, so these are iBGP sessions here in red. If your head is starting to hurt, eBGP, iBGP, IGP, I don't blame you. Let's recap them very quickly. eBGP sessions are sessions that a border router has with border routers in a different autonomous system. Okay. This is how you're going to hear about prefixes that are out in the internet, outside of your autonomous system. This is also how you're going to tell the rest of the internet about prefixes in your own autonomous system. iBGP, sessions between a border router and the other routers within its own domain. This is how you're going to take that information you hear from other autonomous systems and you're going to distribute it within your domain. It's a distribution mechanism to share what you've learned from the inter-domain sessions. Okay? And finally, IGP is Interior Gateway Protocol. You've heard this before in Murphy's lectures. This is just the formal term for an intra-domain routing protocol. It's how routing is done within a domain. This is our distance vector, our link state, the protocol names are OSPF, RIP, everything that we heard in Murphy's lectures. So how do all these pieces come together? Yeah, so if I go back to this AS graph now, I have my links with costs on them within my domain. So within my domain, I'm going to run my IGP, distance vector, link state, whatever I want, my IGP protocol. It's going to compute least cost paths. At this point, I have routes to all destinations within my own domain, including to my border routers or to other routers in my domain. Right? Then with eBGP, I'm going to learn about external destination prefixes. And then I'm going to take those those routes that I've learned, and share them with all the routers in my domain. And every border router is going to do this. This might look not very scalable. We'll come back to that in a bit. But at this point, any router anywhere in my domain has all the information it needs to reach any destination on the internet. Okay? So if I take a router, let's say the one that's going on the path labeled 3, the path it's going to follow, if given a destination prefix outside its domain, is it knows from the iBGP session which egress router, what is the border router in its own domain that it has to exit traffic through to reach that prefix. And it knows from its intra-domain routing protocol how to reach that border router. And so it can reach any destination on the internet. Let's make that a little more specific. So in this case, let's say that the domain where R7 is had a prefix a.b/16. It would have told R1 about this through its eBGP session. R1 would have told all the routers, including R2 in this example, about that prefix through its iBGP session. And so now R2 knows that to get to A.B, it has to reach R1. And it in turn knows how to reach R1 because of the intra-domain routing protocol, the IGP. Let me repeat this one more way, different way, and then let's pause and see whether that made sense, because this is really how all the pieces come together, so it should be clear. So every router in an AS has two routing tables. Conceptually, this is how we think about it. One is from IGP, from running an intra-domain protocol. I have a table that tells me what my next hop is to all my internal destinations. From IBGP, what I learned is which border router or which egress router I should use to get to any destination prefix not in my domain. Okay, so that's like my next hop in some sense is my border router in this case. And so now if I'm given a packet, remember the packet has an IP address, and I'm going to try and forward it. If that packet's IP address is within my own domain, then I just have to look up the table that was computed for my IGP. I look up the destination address, I get the next hop router, I send it on. I'm done. If that address, however, was an IP address that's outside of my domain, I'm going to do a two-step lookup. The first thing I'm going to do is I'm going to look at the prefix for that destination address, and I'm going to know which egress or which border router I have to send the packet towards. And then I'm going to take that border router and say, what is my next hop? Using the intra-domain, because the intra-domain protocol told me how to reach all my border routers. Okay. Any questions on this? Yep.
So the border routers don't all necessarily have to have direct links to interior routers. They will have to use IPv maybe at some point to find the connection.
Yeah, that's a great question. How does the border router reach all the interior routers? It knows how to reach them at the connectivity level because we've run the intra-domain routing protocol. In practice, the implementation BGP actually runs on top of TCP, which we haven't covered yet, but you don't need to know that for now. For now, how do I reach my interior routers? Because my intra-domain protocol built up the paths to them. Any other questions? Okay, is this clear? Anyone want me to repeat it? Okay. So in reality, what I've described to you is one way of configuring how the intra-domain and routing and BGP interact, or how they integrate. In practice, there are a few different ways to configure a domain, and different providers do it slightly differently. The one we've talked about, which is option 1 here, and this is what we're assuming in this class, is that a border router runs IBGP sessions to all the other routers in its domain, both interior and border routers. So if I have n routers in my domain and b border routers, this means I have n times b sessions, IBGP sessions within my domain, which is quite a bit. Depending on the size of your network, this might be a problem. Or if it's not, then this is probably the simplest way to do things. In this class, this is what we assume. Just so you know that there are other ways to configure a domain. Another common one, and I think Murphy touched on this in one lecture, is that a border router will only have IBGP sessions to other border routers, not to interior routers. And then each border router is going to inject that prefix as though it was a directly attached destination address into the IGP. So now you have prefixes being advertised into the IGP. Is that reasonably clear to people? Yep.
So this is then an interior router go to a different border router that then has to forward it to the correct border router?
Yeah, good question. Let me go back to that picture here. So what would this mean? Let's say that this router R1 got A.B, and there's the other border router on the right. Let's call it X. And R1 would have told X, I have a prefix A.B. In this case, this doesn't really work very well, but you could have had R1, let me roll that back. R1 could have just injected A.B as a destination into the IGP protocol itself. So it looks like a destination from the point of view of the IGP protocol. Okay? In this particular case, which is why it gets confusing, let me just say it briefly and then not go any further. R1 could have also told another border router. That border router could have advertised, could have chosen, if it was doing the right thing, chosen not to advertise it as a destination.